Hello everyone, welcome back to the IT for Biomedical Students and Engineers series, part 2 now. We're at part 2. So without further ado, we just continue. So purpose of this training is for the knowledge share, and this training is for the biomedical engineers and students who wants to learn IT. And this is definitely not for the people who are already working in the field of IT, because these are the basics of IT. So the topic we're going to cover today is how the packets gets delivered from a machine to machine. How do they do that? So what do we mean by packet? For example, whenever someone wants to send a data, so they usually call that as a packet. So every data which moves from a computer to computer, it moves as packet from packet. So that's why they call it, they refer that as a packet in the world of IT networking. So don't get confused what it is. You can just consider that as a data. Yeah, a chunk of data. So you can consider that as a chunk of data. So from one computer to other computer, the data moves as a packet by packet. So it moves like faster. So that's what we call it packet. So there are three types of packet transfer happens from machine to machine. Consider this point as a device and this point as one device. So there are three types. One is unicast, the next one is a multicast, and then the third one is a broadcast. So this is a receive device which wants to send the data. Consider this as a source device. So the unicast is the data which moves from the one device to the other device. That's all it does. Point-to-point communications, one-to-one packet transfer. So the multicast is like it comes from one device and it goes to the multiple devices. It's like a copy of it. You are sending it to a couple of devices, not all the devices on your network. So the third one is one device wants to send the data to everybody. When we say everybody, everybody in their particular network. So that's what we mean. All right. So for analogy, so we can take that unicast is like an Amazon delivery. Like for example, you order something from Amazon, it delivers just to you. So it's one to one, right? From you to Amazon, Amazon to you. It's purely from one to one. It's just only one packet was one copy. It comes from one side of the sender to the other side is the receiver. So just as an example, you can say. So same thing with multicast, you can consider that as like a newspaper subscription. For example, in a street, in our locality, you can have 10 or 15 houses, but only few houses are subscribed to a particular newspaper. So only those people will get the newspapers, right? It's something similar. So the multicast, there are so many people on the network, but only few people wants this particular data. So they say, okay, I want to subscribe to this particular data. So whenever the resource send, it will only go to those people who have subscribed for it. It won't reach the other people. So it is not a disturbance. It is not a load. So the load on the network is very less when you use multicast. When you want to send the copy to multiple people. But in a broadcast situations, you are sending it to everybody. For example, you are sitting in an airport, there is a announcement is being made, like the flight so and so is going to get started, the flight so and so is going to get start the boarding. So you are sitting in the airport, though the airport, the flight which they are announcing is not yours, you still hear them. So something like that. So it is being sent to everybody. If you want it, take that information and take it to your head. Same like this. If you don't want, you just ignore it and move on. So that's how it happens. So the informations will reach all the computers, but the computers which needs it will take it further inside, and computer which doesn't need it, it will it still uses the resources to find it whether I need it or not. But still, there is a resource waste, but it won't process the data much because that data are not useful for them, but for some people it is useful. So that's the differences between the multicast and broadcast. But in case of multicast, only the people who wanted it, they get it. But in case of broadcast, everybody get it. So the data is shared with everybody. So we'll take a quick look at each and every of these types of data transfer. One of them, as I said, you have, let's say that this is a network. You have up to 6 devices, but in real life you may have more. So in our scenario, the device 1 wants to send a data to device 5. So it just sends it directly. That's it. So it goes to the switch. Let's take this line as a switch. So it goes to the switch, and then the switch will find, okay, you want to send to data 5, and I have device 5, sorry, device 5 on this particular location, so I will send it here. So simple. There's only one copy which is being sent to the device. So there is a less of a network load on this particular situation. So let's take a multicast. When it comes to multicast, the devices will be sending again. To be honest, if you look more deeper, it will just send only one copy. So the switches will decide, okay, who all are subscribed to that, and then the switch will send one copy to each. So like this. So it's not the device which is sending multiple copies. Device will send only one copy of it, and the copy gets replicated here. So it will be given to whoever asked for it. So the people, the device 2, device 1, they are not disturbed. They stay as it is. Sorry, I made a mistake. This should be device 6. So they are not disturbed. So they stay as it is. So this is multicast. So one to my many, and those many are one who are subscribed to it, who shown interest to it. You can say that way. So in case of broadcast, what happens is you send a copy to the switch, and then that copy is going to everybody, whether you asked for it or you didn't ask for it. This will go to everyone, so except the one who sent it. So when a switch receive a broadcast, it will be sent to all the people. So how does the switch defines whether this packet, which we are sending, the packet which we get, whether it is unicast or multicast or broadcast, how does the switch know, how does the devices know? That is purely based on the MAC addresses. So the MAC address will define whether the packet is unicast or multicast or broadcast. So based upon that, the packets will be transferred to the other devices. So that's it for now. So what you have just learned is just packet is a chunk of data, and the packet, it's not really just the data, it also has too many meta informations like source addresses, destination addresses, MAC addresses of the source, destination. There are so many things, but those things we will look into it in the later stages. I don't want to confuse you. So we will just keep looking at small topics at a time. So for now, you've just learned what is unicast, multicast, and broadcast. These are the type of way that data are being transferred from source to the destination. Thank you for your time. See you on next video.